In Greek mythology, a centaur was an animal that was half man, half horse, armed and dangerous. The Spanish National Police also calls its night patrolmen dedicated to fighting crime centaurs. There is a third type of centaur that is perhaps less known objects that orbit beyond Neptune, and that at some point in their existence change trajectory to enter deeper into the solar system. A perfect opportunity for us to study them from Earth. Two studies published on December 19th provided completely new details about these mysterious bodies, whose orbits are made irregular by the gravitational pull of Neptune and Jupiter, the largest planet in the solar system. The work was made possible by the unprecedented resolution of the James Webb Space Telescope, the largest observatory of its kind. The first of the studies focuses on Chiron, a unique centaur. As in mythology, Chiron is a hybrid object, half asteroid, half comet. Spanish astronomer Noemí Pinilla Alonso is one of the lead authors of the new studies. All the small bodies in the solar system tell us about what it was like in the past, a period of time that we can no longer really observe, she explains in a press release. Active centaurs tell us much more. They are undergoing transformations driven by the heat of the sun and offer us a unique opportunity to learn about their surface and subsurface layers. Chiron is unique in that astronomers have been able to observe both the ices on its surface and the gases in its wake, or coma. Trans-Neptunian objects do not have this type of activity because they are too far away and too cold. Asteroids do not display this activity because they do not contain ice. Comets, on the other hand, show activity similar to that of centaurs, but they are usually observed closer to the sun, and their tails are so dense that they complicate the interpretation of observations of surface ice. Thanks to James Webb, scientists have been able to establish that Chiron, discovered in 1977, has water ice, carbon monoxide, and carbon dioxide on its surface, while its trail is made of methane and carbon dioxide. The study, published in Astronomy and Astrophysics, reveals that Chiron is unique in that it can behave like a comet, with rings of material around it and, potentially, a debris field of dust, or rocky material, orbiting around it. The researchers say the coexistence of molecules in multiple states adds another layer of interest to the study of comets and centaurs. Pinilla Alonso says Chiron originated in the region of trans-Neptunian objects. The orbits of this body and many other large non-planetary objects sometimes experience close encounters with one of the giant planets, whose gravitational pull changes their orbit and takes them across the entire solar system, exposing them to diverse environments, she explains. We know that it has been ejected from the TNO population and is currently just transiting the giant planet region, where it will not remain for long, says Pinilla Alonso. Within approximately 1 million years, centaurs like Chiron are typically ejected from the giant planet region. They can either end their lives as Jupiter family comets or return to the TNO region, she adds. The ices detected, such as methane, carbon dioxide, and water ice, could be primordial components of Chiron inherited from the nebula before the formation of the solar system, more than 4.5 billion years ago. Others, such as acetylene, propane, ethane, and carbon oxides, could have formed on the surface due to reduction and oxidation processes, the astronomer adds. Pinilla Alonso, who has just returned to Spain to carry out research at the University of Oviedo, and Javier Licandro, a researcher at the Institute of Astrophysics of the Canary Islands, published a second study in Nature Astronomy on Thursday, in which they studied other trans-Neptunian objects and made a classification based on their characteristics. Observations made with the James Webb Telescope have made it possible to analyze, in unprecedented detail, the transformations in the surface composition of these objects, highlighting how the sublimation of ice and other thermal processes shape their surface as they approach the sun. This study shows that centaurs are not only an intermediate link between trans-Neptunian objects and comets, but also provide key information on the thermal evolution of icy bodies in the solar system, explained the IAC in a press release. Interestingly, Lecandro explains, a new type of surface has been identified, unprecedented among objects beyond Neptune, which resembles that of active comets and asteroids. The diversity detected in the centaur populations in terms of the presence of water, dust, and complex organic compounds suggests varied origins in the trans-Neptunian population and different evolutionary stages, which highlights that centaurs are not a homogeneous population, but rather a dynamic and transitional group of objects. The two studies are part of the DISCO program on the surface of trans-Neptunian bodies, led by Penila Alonso, currently a distinguished researcher at the Institute of Space Sciences and Technologies of Asturias and the University of Oviedo. Among all these objects, Chiron's features are unique. The body is named after a mythological centaur who was also unique, as he was a wise man who knew medicine and a teacher of great heroes such as Hercules, Achilles, and Jason. This centaur gave up being immortal to help Prometheus, who gave fire to humanity, and instead remained in the firmament as the Centaurus constellation.